All right, integrated math 2 people. So you guys that missed class, we are doing trinomial factoring x squared plus bx plus c, which is the second flap in our giant foldy on factoring polynomials. So you'll need to find that if you don't have that and follow along. Okay, if you open up the foldy, on the top we've got a little bit of a review. So you may be wondering, why are we multiplying them again? Well, we're going to investigate some of the patterns that happen when we multiply these. So remember when we're doing this, that you're distributing everything to everything else, and we use that acronym FOIL just to remember how to do that. So you're going to take x times x, which is x squared, and then you also take the x times 2, which is plus 2x, and then the 3 times the x, which is plus 3x, and the 3 times 2, which is plus 6. And then the last thing is combining like terms. So the 2x and the 3x get combined, and you'll have x squared plus 5x plus 6. So I want to investigate how the numbers in the original problem are related to the numbers that show up down here. There is a pattern that happens. So I go, okay, I've got 5. How is that related to 3 and 2? Well, that's 3 plus 2. And I look at the 6, and I say, how is that related to 3 and 2? Well, that's 3 times 2. So this is a unique case when you don't have a coefficient in front of the x squared. It's just 1. And you also don't have any common factors, but this is just a kind of a cool way that we can use to go backwards to factor. So let's see if we can use what we just saw here to factor this next problem. So I want to point out that this is a quadratic trinomial. So if you go back to those names that we were doing, there's 3 terms. The highest power of x is 2, so quadratic trinomial. And we also do not have a coefficient in front of the x squared other than 1. It's just 1. Okay, so to factor these, we can use this pattern we just saw and do one of those X puzzles like you did on the homework when I was in that meeting. So the 10 would be the number on the top, and the 7's the number on the bottom, and we're trying to find 2 numbers that multiply to make 10 that add up to make 7. So if you think about that a little bit, you'll go, oh wait, that's 2 and 5. So those are the numbers that we're going to use when we factor this. So notice when we're factoring this, there are no common factors for all 3. This has 10, that has 7. This would just be 1 for the coefficients. This has x squared, that has x. This has no x's. There's nothing that you could take out of all 3 terms. So when it's in this format, it's a quadratic trinomial with an x squared term and an x term and a constant term of just 10. We know that it's something that we can reverse FOIL, if you want to think of it that way, and it's going to factor into 2 separate sets of parentheses. And we have to look, okay, what is our variable? So it's using x all the way through, so we're going to have an x and another x. And then this is where our numbers come in. So what do you multiply to make 10 and add to make 7? Well, we just figured that out. It's positive 2, so plus 2. And positive 5. And so for this particular type of quadratic trinomial, there's a really cool pattern that just makes this really easy to figure out.